students, this is matrix and determinants, lesson 3, 4 and 5 classwork correction. We want to take the correction for the combined classwork for lesson 3, lesson 4 and lesson 5. That is scalar multiplication and general multiplication. So lesson 3, 4 and 5 classwork. Number 1, if P is equal to this matrix, evaluate 3P minus 2P. Number 2, simplify. This is matrix multiplication. Number 3, the same matrix multiplication. Then number 4, we want to verify one property of matrix multiplication. Then okay, that's number 4. Number 5, we have 3 matrices A, B, C, and we want to verify another property of matrix multiplication. Then 6 is solving an equation, although we are not multiplying. So this number 6 is from lesson 2, addition and subtraction of matrices. So let's take the correction right away. So number 1, if P is equal to the matrix with entry 2, 5 for the first row, 4, 6 for the second row, evaluate 3P minus 2P. You can say that this is scalar multiplication because 2 and 3, they are scalar or constant. So the matrix P is this multiplied by 3 and multiplied by 2. When you are carrying out scalar multiplication, you multiply each entry of the matrix by the number that is outside of the matrix. So you have 3 times 2, 5, 4, 6. You have 6, 15, 12, 18. For the second part, 2 times 3, 5, 4, 6. You have okay, 2 times 3, okay, 2 times 2, 4, 5, 6. You have 4, 10, 8, 12. 4, 10, 8, 12. Then you subtract. You know, when subtracting, the order must be the same, and that is true. So you have 6 minus 4. You have 2. 15 minus 10 is 5. 12 minus 8 is 4. 18 minus 12 is 6. Now, if you can see very well, you notice that there's even no need to solve at all. Why? Because 3P minus 2P is equal to P, and P is the matrix itself. So actually, no solving is required. No solving is required. So I did it this way so that the way you understand it, that is how you tackle the problem. Okay. Number 2, we are to multiply. So what I did first is to write the dimension of the matrix. I want to verify if the condition for multiplication is satisfied. That is, the number of columns in the first matrix is equal to number of rows in the second matrix, and they are equal. Therefore, multiplication is defined. Then your answer is going to be a 3 by 1 matrix. That is the 3 rows that are left here and the 1 column you have. After checking that the number of columns and rows are equal in the first and second matrix, the remaining order 3, 1 is the order for the solution. So in this place, you take the first row to multiply the only column that will give you the entry in the first row. You can see them here. Then the second row of the first matrix to multiply the only column of the second matrix, that gives the second entry in the solution. Then the third row multiply the only column you have, that is the third entry. You see that? Element by element. So if you check if you take the first row, you have 2 multiplied by 2, that is 2 times 2 you have here, then plus, remember the sum of product. Then you take 3 multiplied by minus 1, that is what you have here, plus you take 1 multiplied by 3, that is what you have here. So you do that for the rest row. At the end, your answer is going to be 4, 13, and 10. So you have 3 rows. 4 is 1 row, 13 second row, 10 is third row. Then you have just 1 column, 4, 13, and 10. So you must check that the number of rows, the number of columns in the first matrix equal to the number of rows in the second matrix before multiplication is defined. Are you following? Okay. Number 3, the same multiplication. So what I did first is to write out the dimension. This is 2 by 3, that is 2 rows, 3 columns, and this is 3 by 2, 3 rows, 2 columns. The number of columns in the first matrix is equal to the number of rows in the second matrix. That means multiplication is defined, and our solution is going to be a 2 by 2 matrix. Number of rows now in the first matrix and the number of columns in the second matrix. So after that, you take the first row to multiply the first column, and you have this result, entry by entry. The same first row times the second column, you have this result, entry by entry, that is 1 times 2. You have this, 2 times 1. You have this, minus 1 times 0. You have this. When you are done, you take the second row to multiply the first column. You have this result, that is 3 times 1, 1 times minus 2, 2 times 3. You add, and the second row times the second column. You have this entry, that is 3 times 2, 1 times 1, 2 times 0. By the time you multiply, you have this step here, and when you add and subtract, you have the matrix with entry minus 6, 4 as the first row, second row 7 and 7. Okay, so this is how you multiply. Number 4, given that matrix A is this and matrix B is this, the two matrices are 2 by 2 matrices. Show that A times B transpose is equal to B transpose times A transpose. Okay, so already we know the two matrices, so let's get their transpose. This is matrix A, so let's get matrix A transpose. We define transpose as a matrix obtained by interchanging the row of original matrix for the columns, or you interchange the columns for the row. So in this place, if you take the first column, you make it the first row. See that? You take the second row and you make it the second column. Second column. Right? you take the first row and make it the first column. You take the second row and make it the second column. Then for matrix B, you take the first row and make it the second and make it the first column. In the transpose matrix, you take the first row and make it first column. You take the second row and make it second column. So let's take the first part. In the first part, we need to carry out multiplication of matrix A and B. So in the usual operation, the first row times first column times second column, that gives this entry and this entry, element by element. I'm sure what I'm doing now is not strange to you again. Then you take the second row to multiply first column and second column, element by element. That gives you this and this. When you multiply first, you get this step. That is 1 times 5 is 5, plus times minus there is minus. Then you have 3 times 1 is 3. Same thing you do to the next entry in the first row. The second row, you have 4 times 5 is 20, plus then minus become minus. 2 times 1 is 2. So when you add, you have this result. Remember, in the first part, we need the transpose. So the transpose, you take the first row and make it the first column, and you take the second row and make it the second column. That is the first part. So let's get the first part. Let's get the second part now. B transpose times A transpose, and see if the result is equal to A B transpose. Okay, so the second part, B transpose times A transpose. So this is B transpose, this is A transpose. They are also 2 by 2 matrices. So in the first matrix, you take the first row to multiply the first column and second column. That gives you the entry in this place and the entry you have here, element by element. Then you take the second row to multiply the first column and second column. That gives the entry in the second row. When you multiply and add, you have this step. Then after adding, finally you have the matrix with entry the first row, 218 minus 1 minus 4. So let's compare. This is the result for AB transpose. This is the result for B transpose times A transpose. So what we are asked to prove is true. That property is true for matrix multiplication. That is the meaning. Okay. Number 5, we have 3 matrices A, B, C, and we are asked to show that A times B plus C is equal to AB plus AC. This property is distributive property of matrix multiplication. So we take the first part. In the first part, following the rule of Bodmer's, you have to deal with the bracket first, and the bracket is B plus C. That is addition of matrix B and C. So when you are adding the first entry here to first entry, that is 6. Then second entry minus 2 plus 3, you have 1. The second row, you have 8 plus 0, that is 8. Then the same second row, the last entry, 1 plus minus 4, that means 1 minus 4, and that is minus 3. So let's multiply B plus C by A. So this is matrix A, this is matrix B plus C. If you use the first row to multiply the first column, after adding you have 66. The first row times second column, after adding also you have minus 2. Then you take the second row to multiply the first column, after adding and multiplying you have 8. Then the same second row times second column, you have 10. That is the first part. The second part is AB plus AC. What it means is that you look for the product of AB and the product of AC, then you add both together. So this is AB. You take the first row times the first column. Now let's check that. 7 times 5, that is 35. 3 times 8 is 24. When you add 35 plus 24 is 59. So you get that? The same first row times second column. If you do what I just did now, you have minus 11. You come to the second row times first column, you have 4. Then second row times second column. Now let's do that. 4 times minus 2, that is minus 8. Then minus 2 times 1 is minus 2. So minus 8 minus 2, you have minus 10. So let's take AC, that is A times C. This is matrix A and C now. You take the first row times the first column, you have the first entry, that is 7. The same first row times second column, you have the second entry, that is 9. Then you move to the second row times first column, you have the first entry, the second row as 4. Second row times second column, that is 4 times 3 is 12. Minus 2 times minus 4 is minus 8, is plus 8 plus 8. Minus 2 times minus 4 is plus 8. If you add that 8 to 12, you have 20. The second entry in the second row. After that, you add AB and AC. This is matrix AB, this is matrix AC. So if you add 59 plus 7, that is 66, minus 11 plus 9, that is minus 2. 4 plus 4, 4 plus 4, you have 8, minus 10 plus 20, that is plus 10. So let's check. A into B plus C is this matrix now. Then AB plus AC is this matrix, and you find out that both results are equal. This shows that the distributive property of matrix is true. So lastly, that's number 6. We have 3 matrices. The first one contains letter. The second and third, they have entry. Then you are asked to find P, Q, R, O, S if A is equal to B minus C. So this is what you are asked to look for. So matrix A is this now. This matrix B minus matrix C. So if you subtract 4 minus 7, you have minus 3, minus 3 minus 2 minus 2, you have minus 5. Then 2 minus 2 minus 1, 2 minus 1, you have 1. And 3 minus 3, it's like you have 1 minus 3, the same thing as 1 plus 3, and that is 4. So the next thing here is that you invoke equality of matrices, where the first letter here, P, is equal to the first entry, that is P is equal to minus 3. Arrow, the second letter, the first row, is equal to minus 5, you have minus 5. Then Q is equal to 1, and S is equal to 4. So this is the correction to the classwork of lesson 3, 4, and 5. Okay, for updates, for more lessons, follow Peter Course Educom via YouTube at Peter Course Simplified Maths. To do that, subscribe to this channel, like this video, very important, share the video to your friends, your classmates, your colleagues. You can also follow us on Facebook at fb.me/petercourseeducom, Instagram petercourseec, Telegram t.me/petercourseeducom, WhatsApp through this mobile telephone number. All right, thanks for watching and learning with Peter Course Education Community. Take good care of yourself and stay out of trouble.